everybody. Welcome to the video here for lesson number 7 on secants and tangents, just talking about their angles today. So we're going to learn a couple of new vocabulary words today, secants and tangents being them. But before we do that, let's try the opening exercise. So it says in a circle, attempt to draw and sketch 3 lines, one line that intersects a circle once, one line that intersects a circle twice, and a line that intersects a circle 3 times. See if you can do this. Take a moment, pause the video, and see how you do. All right, so welcome back. Hopefully you tried it on your own. So here's a line that intersects the circle 1 time. Remember, lines go on forever, so you can't just draw one that like starts in the circle and goes out. That would actually touch twice. I draw a line that touches twice. However, this last one is impossible. Now, the 2 lines that I actually was able to draw, one of them is called a tangent line, and one of them is called a secant line. Now, these 2 words have a lot of different meanings. For this course, for this unit of circles, we're just referring to them as the lines and the angles and segments that they create. In next year's course in Algebra 2, we'll learn a lot more about where these words come from and why they're so important in trigonometry. For this class, we're not going to do any of that. So, let's talk. A secant line, a description of that is a line that has 2 intersections on the circle. It's kind of like a chord that extends outside of the circle. A tangent line is a line that we're going to say touches, not the best math word, touches a circle once. The reason why I'm saying touches, because it almost like kind of just touches the circle here. So we say that line is tangent to the circle. So let's talk about the rules that are created here. An angle formed by the intersection of a chord and a tangent will be equal to half of the measure of the intercepted arc. So this is talking about a chord and a tangent. So we're going to have this kind of weird looking angle, like the picture here in exercise 1. So here's your chord. CD is your tangent line. I know it doesn't extend forever, but we could make it extend forever, right? So it looks like the definition we said above. And it says the angle formed, this angle here, is equal to half of its intercepted arc. So if y is 320 degrees, I can say x is equal to half of that. So x is 160 degrees. Exercise 2 gives us a similar picture. So it says, in the circle below, the measure of the minor arc AC, so that's this little arc here, is 4A, and the major arc is 14A. And it wants us to find the angle of x. To find angle x, I need to find whatever this measurement is. Now, these 2 arcs together make up the entire circle. So I can say the small arc, 4A, plus the big arc, 14A, has to equal a whole circle, 360 degrees. That should help me figure out what A is. Do some algebra here. And we now know A is 20, making this angle or arc 80, and this arc 280. Now, if this arc is 280, the angle that's created by that arc is going to be half of that. So that angle is going to be 140 degrees. Now, this rule that we just went over is one of those rules that doesn't come up that often. That's why there's only 2 examples. The bigger rule that we're learning today is what happens when we intersect secants and tangents, not chords and tangents. So there are 3 different things that can happen when secants and tangents intersect each other, and the 3 pictures are right here below. The rule is the angle formed at the intersection of the 2 secants, 2 tangents, or 1 tangent and 1 secant is equal to half of the difference. So this time we're subtracting. So unlike the last lesson where we added, we're going to subtract these arcs this time. And the arcs that we're subtracting are the arcs that are inside of that secant or tangent line. So this arc and this arc we're subtracting, this arc and this arc we're subtracting, and this arc and this arc we're subtracting. So let's just jump right into a couple examples here so we can see what we're doing. I'll try and use highlighters as much as I can to kind of help guide you to what I'm looking at. So it says two secants intersect outside the circle to form an angle of 42 degrees. So what does that picture look like? We have a circle, we have a secant line, we have another secant line, and the angle formed when they intersect is 42 degrees. It says the larger of the two intercepted arcs is 168. This is the smaller one. This is always going to be the bigger one. The one furthest away from the angle is bigger. And we don't know the smaller arc. So when I'm looking at this, I want to subtract this arc and this arc to get this angle. So when I'm subtracting, I'm going to say, all right, the angle, which in this case is 42, is half of the difference of the two arcs. And then this just becomes an algebra problem again. Multiply both sides by 2. 84 is equal to 168 minus x. Subtract 168 to the other side. 84 minus 168 is negative 84. So we could say negative 84 is equal to negative x. So then we know that 84 is equal to positive x. So that smaller arc is 84 degrees. Number 4 says two tangents intersect outside the circle to form an angle of 80 degrees. What does two tangents look like? It's going to make like this little cone, right? They intersect just one time on the circle. The angle on the outside is 80. Now notice, this time they don't give me arcs. The reason why is when two tangents intersect, the entire circle is used. So if I make the smaller arc x, the bigger arc would have to be 360 minus x. So I could say the angle is equal to 1/2 of the larger arc minus the smaller arc. Multiply both sides by 2. So I have 160 is equal to 360 minus, we'll say, 2x. Subtract 360. So I have negative 200 is equal to negative 2x. Divide by negative 2. And we get x is equal to 100. So the smaller arc is 100 degrees. The larger arc is going to be 360 minus 100, which is going to be 260 degrees. Example 5 has 3 different questions. They're all very similar. I'm only going to do the first 2 because they're all very similar. So we have these arcs here that are created. So if I take the angle and say half of the two arcs, remember the larger arc is furthest away. Notice I put a parenthesis around this entire arc here because I'm subtracting this whole thing. I'm going to multiply both sides by 2 first because I don't like that 1/2 there. I'm going to distribute. And then combine up some like terms, see what you get. So if I combine 19 and negative 9 and 30, negative 31 and positive 21, I'm going to get 10x minus 10. If I subtract 6x, I have to try and keep my x's positive if I can. Add 10 to both sides. I have 44 is equal to 4x divided by 4. And I get x is equal to 11. Now it says to find the value of x and determine the measure of the angle on the outside. So if x is 11, 3 times 11 plus 17 is 33 plus 17. So that's 50 degrees. That's this angle here. All right. Part B is the same thing. I'm going to take the angle on the outside, 15x. And say that's 1/2 of the difference of these two arcs. So 55x minus 2 minus 48. No need for parentheses here because this is just a single number. I'm going to pause the video. Try and solve this algebraically yourself. All right, so let's see how we did. So the first thing I did is multiplied both sides by 2. I combined like terms. I solved, and I got x equals 2. I then plugged 2 in to find angle E as 30 degrees. Again, part C is very similar, so we're going to just skip it just to save time, and we can go from there. So, good point to stop the video, try the homework, see how you do. All right, so welcome back to the video. Let's see how we did. So we have a ratio here in number 1. We love ratios. So it says the measure of an angle formed by two intersecting tangents. So what's that look like? So I have a circle, I have a tangent, I have a tangent. And it says we want to know this angle, so we don't know it. So we're going to say it's x. Intercepted arcs. So these two arcs are going to be, we'll say 7y and 2y. I'm using y because I already labeled the other thing as x. So because it's two tangents, I know these two arcs, 7y and 2y, have to add up to 360. So I can figure out what y is. Y is 40. So if I redraw this picture and say, I want to know this angle on the outside, and this arc is 80, and this arc is 280. Right, 7 times 40 is 280, 2 times 40 is 80. How would I find that angle? I'd say that angle is equal to half of the two arcs subtracted. So I'd say that angle is 100 degrees. Ratios is nothing that we did in the lesson, but it's something we've been doing the whole school year, so we should be able to do that. Number 2 is starting to get us to think how a big circle question is going to look. So big circle questions have tangents, chords, secants, they have all kinds of different things. We have to decipher what they're telling us and what we know and what we can figure out from that. So it tells us the first thing is angle BAC is 72. That's a central angle, so I already know arc BC is 72. That's one of the things they want us to find, so we knew that right off the bat. It then says that arc BE is 96. Now to find arc EFC, right, EFC, I know that that's the remaining arc of this circle. So if I take a full circle, subtract the two arcs I already know, I should get that remaining arc. So if I do 360 minus 96 minus 72, I'm left with 192. That's this big arc over here. So they want us to find arc EBC. EBC. So if I do EBC, that's 72 plus 96, 168. They want us to find arc EFC, which we just found, 192. And they now want us to find angle D. Angle D is on the outside of the circle. So to find angle D, I would say that's half of the difference of the two intercepted arcs. Notice I'm using 192 and 72. I am not using 96. That is not part of this intercepted arc situation here. So if I do 1/2 of 192 minus 72, I wind up getting angle D as 60 degrees. Number 3, if you tried it, I apologize. This comes out to be a system of equations. This should have said accelerated only. My bad. If you did it and you got the right answers, or you think you got the right answers, email me, I'll tell you. But it does come out to be a crazy system of equations, not anything I would ever ask you as we move forward. Hopefully that video helped, and hopefully you got those 2 homework questions right that I had you try, and I hope to see you soon.